Okay, good afternoon, everyone. Thank you so much for joining us today. My name is Vanessa Cadle, and I'm the Senior Strategy Director for Math Pathways and Corequisite Remediation at Complete College America. I have the privilege of serving on the Idaho Math Pathways team, and I frequently join in on the calls hosted by Dr. Brunfield, the Chief Academic Officer. It was on one of these calls that issues about college algebra corequisite support came up. And so Complete College America went to work to find an expert on the topic to provide Idaho with some targeted technical assistance. And we're so pleased today to have Dr. Chris Francisco with us. He is an associate professor of mathematics and the associate head for lower division instruction at Oklahoma State University. He frequently works with CCA as a content expert, and he's going to be sharing his experience with you, as well as answer any questions you may have. So I encourage you to use the question function on this webinar to submit questions as he presents. And when Dr. Francisco is completed, I will facilitate a question and answer session with him. The good news is I'm also recording this webinar, so you can share it with any of your colleagues who were unable to join us. And I plan to send the webinar link out early next week to you, so you can share it as you see fit. Thanks so much again for joining us, and I'm going to turn it over now to Dr. Francisco.
All right, thanks very much, Vanessa. I appreciate it, and thanks for inviting me and for being with us today. I'm going to try to talk today about our implementation of co-requisite mathematics instruction, and I know there's particular interest in the college algebra, and so that's what I'll focus on today, although we've got it implemented in a couple of courses right now. What I want to do today is give you a little historical context for kind of where we were before we started co-rec instruction, what our setup is like at OSU, what some of the results are that we've had, and then some of the other things that we feel like goes along well with the co-requisite instruction that I think is helping our overall efforts to get more students through entry-level mathematics. So let me start with the historical context prior to co-requisite instruction. OSU is a research university, and so we have a lot of really strong students. We teach doctoral courses. But at the same time, we're a land-grant institution that draws from a lot of populations that are underserved, that don't have the same sort of resources that some of our top students might have, some of the advantages in high school. And so we have a lot of students who come in who are very talented and have a lot of potential, but have not had the same sort of rigorous preparation that other students have had and struggle when they start their entry-level mathematics courses. So the way the state regions had things set up in the state of Oklahoma is that no developmental courses would be taught at the research institutions. All of these were taught at a local community college. So for us, we have a community college in Stillwater that's across the street, and students who needed math remediation would just walk across the street and take the course over there and then try to come back and take our courses after that. Unfortunately, the DFW rate in intermediate algebra, so the highest developmental course in our system, was roughly 50%. So those students were, about half of those students weren't succeeding in that course. And then if you take the 50% of the students who did succeed in the intermediate algebra, they still never enrolled in a college level math course. So we had a lot of attrition between the remedial course and the college level course, even among the students that succeeded. And I think that's a pretty common thing nationwide, and it's indicative of a structural problem in how we're doing these things. OSU was fairly early on in the math pathways trend, and we've had them for over 20 years now, and I think it's been very helpful to have math pathways, and I think they complement co-requisite instruction well. But it doesn't solve all the placement issues, and I think it has to work in conjunction with co-requisite instruction to really be as successful as it can be. The other issue that we've had is that many prospective STEM students didn't have an official state remediation requirement, but they couldn't qualify for our college algebra class based on the placement test that we used. They just weren't well prepared for it at all, even if they had an ACT score that was 19 or above and technically satisfied those state requirements. They still weren't getting to the level that we thought they needed to get. So let me talk a little bit about what our current placement scheme is and give an overview of our co-requisite instruction, and then I'll talk more specifically about exactly what we do in college algebra and how we run these things. So we have, since the summer of 2012, used the ALEKS placement test as an initial screen for courses through Calculus 1. So students get 5 attempts at this placement test, they have access to 6 months of free online learning modules and free tutoring that we offer in our Mathematics Learning Success Center, our tutoring center that we built. The students who take these learning modules seriously tend to do very well. They may not do so well the first time they take the placement test, but they study, they work through the learning modules, and they tend to improve their score quite a bit, often going up 1 or 2 courses in the ladder after they do that. So we are not a big fan of high stakes, one-shot placement testing. We are a fan of having a placement scheme that allows us to test what students know when they're about ready to enter college, and that summer before their freshman year. We feel like that distributes students appropriately, and as long as we give the opportunity for them to move up through this online learning module system and through the tutoring that we offer, we feel like we're providing students the opportunities that they need. So on that ALEKS placement test, I don't know how many of you are familiar with them, but it's a scale of 100. The cutoff for regular college algebra is roughly what ALEKS recommends, just a slight decrease actually in what they recommend, 45 out of 100. For those are for our regular sections of college algebra. For our co-requisite sections of college algebra, students who earn between 30 and 44 can take those. So the reason we picked 30 is that that was the recommended cutoff that the ALEKS people said for intermediate algebra. So we are capturing all of the students who would have originally placed into the intermediate algebra course, the highest level of developmental mathematics that we offer in our system. And we have found that that's been a perfectly reasonable cutoff. We have the same sort of scenario for our same sort of setup for our non-STEM math modeling course. We have a course that is taken by a lot of business students and some social science students that leads into business calculus and disciplinary statistics courses. We have basically the same setup. It's just that our cutoffs are lower because that class doesn't require as much formal algebra training. Our co-requisite sections meet 5 days a week instead of 3, and we use those additional 2 days per week to provide the extra support that we feel the co-requisite students need. I'll talk more about that in just a bit. I do want to emphasize that the co-requisite sections are taught with the same rigor and the same exams as the regular sections. So we have common exams in our college algebra classes. Everybody takes the same ones. We look at the scores at the end of the semester and grade it exactly the same way. There is a slight difference in the co-requisite sections course requirements because the students do a little bit of extra work on those Tuesday and Thursday class periods, but otherwise the grading is essentially exactly the same. Right now, we are running 3 co-requisite sections of college algebra each fall, and that meets about 3/4 of the demand. I'd like to be able to run a 4th one starting next year. We have 2 fall sections of co-requisite math modeling for non-STEM majors. That meets essentially all the demand. I think that we even had 1 open seat in those 2 sections this fall. So we're doing pretty well as far as meeting that demand goes. So let me tell you about the co-requisite model we're using in college algebra right now. When we set this up, we decided that since most of the students who are coming in are new freshmen, first semester freshmen, we wanted to try to mimic some of the high school experience as much as possible. So we decided we would have the classes meet 5 days a week for 50 minutes at the same time every day. And the idea is they just get used to going to math class at 10:30 every day. They have math, every day they're in school, just like they did when they were in high school, at least for those who aren't on a strange sort of schedule. And in doing that, we try to make sure that they're working consistently on math every single day. The Monday, Wednesday, Friday versions of the classes of the co-requisite sections are essentially the same as the regular sections. So you'll have an instructor there. They'll be covering the main course material. An undergraduate learning assistant that we employ to help with these sections will sit in on the course, but the learning assistant on those days, on Monday, Wednesday, and Friday, mostly is just kind of taking it all in and looking to see what the notation is used in class, what sort of things the instructor is emphasizing, where the students might be having trouble, and if there are any kind of group activities going on during the class period, the learning assistant will walk around the room and help the instructor with those. But the Monday, Wednesday, Friday co-requisite classes look basically the same as the regular classes. The big difference is on the Tuesday and Thursday days of the week. So on the Tuesday and Thursday, the learning assistant is really running the section, him or herself. The regular instructor does not come to that class period except at the very beginning of the semester. The course coordinator has developed activities that the students will be doing in these Tuesday, Thursday classes. So there's essentially no lecturing going on. Basically, the instructor, the learning assistant, will introduce an activity. We'll talk maybe for a couple minutes about it, divide the students up into groups. Students will work, 10 minutes on one activity, and then they'll all come back together and they'll demonstrate their solutions. They'll talk about where they had trouble. They'll fix things that they didn't do correctly, and then they'll repeat the process with another, couple of problems during the course of the hour. At the end, the expectation is that all the groups will understand what had gone on those problems, and will be able to turn in those problems at the end of the hour so that they don't have additional homework. We're very sensitive to the idea that we don't want to give extra things for the students to do outside of class in addition to the normal class homework that they're already doing, because this is an extra workload for them, and they're already coming in a little bit behind everybody else. And so we want to provide good quality support during those 2 50-minute intense periods that they have during the week, but not give them extra stuff to do outside of class. The course coordinators that have done this are very organized, very well prepared in the materials they hand over to the undergraduate learning assistants so that they have a very clear outline of what they're supposed to do and when they're supposed to do it in class. We are not using graduate students for this, and we're not using lecturers for this for a number of reasons, in part for financial reasons, in part for personnel reasons. We're in a relatively small college town. We don't have a lot of extra personnel available to us, and so we do have a lot of undergraduate math education majors and engineering majors and math majors who are interested in doing this kind of thing, and who have done just a tremendous job, better than I ever would have expected, actually, in leading these sessions. And so they're a great resource for us, and we can afford them an opportunity to get some of this teaching experience that some of them really like before they go teach high school or they go to graduate school or do something else. The two types of activities we do in these co-requisite classes on Tuesday and Thursday are refreshing memory on the prerequisite material. So, just-in-time instruction, I think, is a term that's used a lot, where if we're going to talk about logs the next week, we make sure they remember all the rules for exponents, because they're not going to have a very easy time with logs if they don't remember what they're doing with exponents. We also give a lot of extra practice on college-level course material, and in fact, that's really what we do most of. It's evolved that way, and I was kind of surprised in the end that that's what we needed to do to be most effective. But it seems like a lot of these students just need extra practice. They can remember what it is that they need to do once they've seen a lot of examples of things and they've had a lot of practice on the college level material. Their memories kind of get jogged on the prerequisite material at the same time. We have not had a lot of activities where we're specifically trying to focus just on prerequisite material. We're trying to integrate it into what we're doing in the course material. We also give, just the usual pep talks and discussion of work habits and that sort of thing in these co-requisite sessions on Tuesday and Thursday. We got a lot of first-generation students in these classes, and one of the things that has been really rewarding to us is to see how successful they've been. But they have special needs. They don't have necessarily family members they can call up and say, how should I study differently from a college course as opposed to a high school course? That's something that we have to help provide for them, and that's one of the things we'll talk about in the co-requisite sections. So how do we implement this logistically? Let me preface this by saying that every institution is different. Every institution has its own unique needs and resources and idiosyncrasies. So I don't want to suggest the way that we have set it up is the right way to set it up. I think it was the right way to set it up at OSU, given all our constraints and the issues that we have, but there may be other ways to do it that are just as good. The way we've set this up is we have specially designated co-requisite sections of our courses. That is, College Algebra is Math 1513 here. So we'll have 20 sections of Math 1513, and then we'll have 3 additional sections of Math 1513 that are designated as co-requisite instruction sections. The students, when they go to enroll, will see in the system that there's a 5-day schedule for those sections only, and the rest of the sections meet either just Monday, Wednesday, Friday, or just Tuesday, Thursday. So the students can see which sections are which that way. We elected not to have an additional co-requisite course, so there's no 0-level lab or discussion section or anything like that, like a lot of institutions do. We did that first because we initially weren't allowed to because of state regents rules, even after those got relaxed, we didn't really want to attach that course to the co-requisite class. We felt like it would be better to advertise to students that this is the same course. It's just you need another extra couple of days a week for extra support. We did not want students to have this zero beginning course on their transcript, which might indicate to prospective employers that they weren't, skilled at math, or that they took a watered down course or something like that. We wanted a clean sort of, just on the transcript, it just says Math 1513 College Algebra. It doesn't distinguish between the two courses. We feel like if you, take the same exams as the regular course, you ought to have it transcripted in the same way. We don't give any additional credit hours for it. This was another kind of philosophical decision, that if you are taking a 3-hour college algebra course and we're just providing extra support, you shouldn't get extra college level hours for that extra support. You're just getting the extra practice. We have not charged additional tuition either. We initially got some money from a local foundation that was interested in helping get students out of remedial mathematics courses and into college level courses faster. And so we got some seed money from them. I'll talk a little bit more about funding later on. But that's how we have it set up. We don't require additional tuition for the courses. We would really like to be able to test for this 30 to 44 range in Banner and have this automatic so that students could just enroll themselves. Banner can test to see if a score is greater than or equal to a number, but it apparently, at least our version of it, cannot test to see if a score is in a certain range, which makes no mathematical sense, but this is what I'm told that the restrictions are. We've explored every possibility. We've tried to, tack on a minus sign to the score and see if we could flip the inequality. We've tried lots of things and nothing seems to work. So we have departmental permission on the co-requisite sections to make sure the right students get enrolled in them. Advisors in this painful sort of process email departmental staff and me to get permission for students to enroll in Banner, and we have someone monitoring that email address during new student orientation and then less often throughout the semester, and we grant the permission electronically in Banner. Right now, we are proposing a small co-requisite fee, now that our seed money is running out, of about $90 per student. So that will cover learning assistance and development of course materials and continuing revision of those materials. I would, prefer not to charge at all for these kinds of things, but of course, there are limited resources at universities. And if you think about the $90 fee, a lot of these students will be paying remedial tuition or remedial fees and having a delay in their time to graduation by taking an additional semester. If we do this, they're paying a $90 fee, but they're getting in the college level course right away. And in addition, they're getting roughly 30 hours of a semester of this extra support that we're providing. I think it's really a pretty good deal for students. So let me give you some indication of the results that we've gotten in college algebra. This is from our very first cohort in fall 2015, and you can see what our overall success rates were and what our enrollments looked like. So we had 733 students in non-correct sections and 87 students in correct sections. You can see the non-correct sections fared just a bit better than the correct sections. And we were actually shocked at how close those were. When we did our early semester diagnostics of the correct students, they were scoring, well, in the assessment we used, there were 120 topics, I think. They were scoring around 40 topics correct. The regular students were scoring about 70, 75 of those topics correct. And so there was a pretty big gap between what the co-requisite students knew and what the non-co-requisite students knew. And by the end of the semester, they were doing almost as well as the regular students. You'll also notice there was a much higher proportion of first-generation students in the co-rec sections. That first-generation success rate was something we're very, very proud of. The students in the first-generation co-rec students did extremely well. They did better than students in the non-co-requisite sections. Overall, one of the things that I think most important to keep in mind when evaluating these types of things, before we implemented this co-requisite instruction setup, we were only getting half of our students through the remedial math sequence anyway. And then of those 50%, many of them either didn't go on to college algebra, or if they did go on to college algebra, you can see at the bottom of that slide, only 30% of them were getting a C or better in the class. So, we were getting fewer than 20% of students through college algebra at OSU if they started in remedial mathematics. If you look at this group here, we're getting about 2/3 of the students through. And I think that's very important to us to be able to have that big of a jump in performance. The other thing that was really fascinating to us is we tracked these students who succeeded, who got a C or better, and we looked to see what they did in spring 2016 in a subsequent math or stat course. These students were taking a variety of classes. Some of them were taking just an elementary or business statistics course. Some of them were taking trigonometry. Some of them were taking business calculus. And you can see that the success rate was sort of astonishing. It was 83.7%. These students were not taking co-requisite versions of the next course. They were just kind of randomly put into whatever course they happened to enroll in, whatever section they happened to enroll in of a subsequent course. And they performed extremely well. The instructors had no way of knowing whether the students had had regular college algebra, co-requisite algebra, and the success rate was way beyond what we would expect for our normal student population. I will say that this rate is much higher than we saw last year. Last year we saw more like the high 60s, I think low 70s, but it was still, for students who are going to start in remedial mathematics and who only had a less than a 20% chance of getting through one college level course in 1 or 2 years, to have them have 2/3 of them get through the college algebra in 1 semester, and then another 70% of them or so get through a second course. That's really, really phenomenal, I think. Let me give you some updated information about our fall 2016 cohort that we looked at, and I want to be precise about what these data are here. It looks a little funny. When we did the fall 2015 data, we separated it out into co-requisite students and non-co-requisite students. Included in the non-co-requisite students was a group of about 30 students who took online college algebra. And of course, online classes at the 1000 level tend to be a disaster, especially when they're populated with local students. And so that DFW rate was pretty high, and we felt like we might be doing an unfair comparison there, making the non-co-req sections actually look worse than they really were. And so we changed the way we collected the data, and we haven't gone back and redone the numbers for fall 2015. But for fall 2016, we have eliminated the online section from the standard section line, so that we have a fairer comparison, so that we don't artificially make those sections look bad in trying to make our co-req sections look good. What you'll see in the fall 2016 performance is that the co-req sections actually outperformed the standard sections. And this was pretty surprising to us. Our goals initially were to basically have the co-req sections not trail by too much. They wouldn't lag by more than 5 percentage points or so. They actually did better than the standard sections, and they did better both among first-generation students and among the entire population. The students in the co-requisite sections tended to report that they were very happy with the sections. The main complaint came from the students who were very close to the cutoff. So a student maybe who got a 43 or a 44 on the placement exam and felt like they didn't really need the co-req sections. Those are the students who sometimes stop showing up on the Tuesdays and Thursdays and unfortunately tend to fail. The students who are very low, like a 30, 31, 32, they tend to be very happy that they're able to take the course, and we've had a lot of them do very well and earn A's in the class because they work very hard. I think one of the things I want to emphasize here is that we are very much not reinventing the wheel here. We are, taking this co-requisite model, which I think works very well. I was kind of skeptical of it when I first heard about it until we tried it, but I think it's worked very well for us. And when we're developing these activities for the co-requisite sections on Tuesday and Thursday, we're not trying to do anything extraordinarily innovative or develop something that takes a lot of work to maintain or anything. The question that I've asked our coordinators is, okay, if you had 2 extra days a week in college algebra and you weren't trying to cover more content, but you were trying to enrich the student's experience, you were trying to make sure that they understand things better, what would you do during those 2 days per week? And can you develop some sort of relatively simple activity that we could do on those Tuesdays and Thursdays? And that's what we've done. I think the students see that this material is tied very closely to what they're doing in class. And one of the difficulties with remedial math is that, you do intermediate algebra for a semester, you don't really see how it's used in college algebra. And then when you get to college algebra the following semester, you don't remember what you haven't used for a month, 2 months, or whatever in your intermediate algebra class. So we've tried to be very careful about the things we've developed, tie it in very closely to the college level material that we're doing in the class, and make sure that the students see the utility of it. Let me give you a little bit of other data that we have here, including some financial sort of information. So in the fall 16 and spring 17, our last academic year, in both college algebra and in our non-STEM modeling pathway, in each of those semesters, in each of the courses, the co-requisite students outperform the students in the standard sections. So our spring DFW rates are always a bit higher than our fall DFW rates. I think that's fairly standard across the country. But even though those were higher, the co-req students still outperformed the regular sections, which was very gratifying for us to see. Some of those students who started in fall 2015 who are in a STEM pathway have actually gotten through one of our calculus sequences. So a number of them have gotten through the tech calculus sequence, which is for the engineering technology majors, not the standard electrical engineers or mechanical engineers, but kind of a level below that. They've gotten through our tech calculus sequence. I saw one student who is in the regular engineering track is all the way through differential equations already. So we're really delighted to see these students who would not have qualified for a college level math course their freshman year, who got into this co-requisite path and actually have gone through. One of the questions that everybody has that's a real issue when you're implementing anything is what's this going to cost us? And I'll tell you what we set up in our system here, and of course your systems will be different depending on what resources you have available, how you're going to structure this, what kind of personnel you have. For us to run a section of co-requisite math, basically we pay our learning assistants $2,000 a semester. We have to compete with all the other jobs on campus and the waiting tables jobs and these kinds of things. And so 2,000 seems to be the magic number that gets us the top people. And it costs us roughly $800 just to account for the fact that we have these in sections of 30 as opposed to 35, 38, 40, which is where we run a lot of our college algebra sections instead. So that's about the money that it costs for each section. We also, of course, had development costs. We had to develop all these course materials, and I think it's very important as administrators to recognize if someone's doing something extra that we don't just dump extra load upon them, that we give them release time or we compensate them for it. We decided to give summer salary to people who were developing these co-requisite instruction materials. So we gave 1 month of summer salary for the initial development and a half a month of summer after that. We're looking at ways we can provide some continuing revision money, some small amount each year or some lump sum every few years as courses change and pedagogy change and you decide you want to revise what these materials look like. The question from central administration for us was, one, is this going to help retention? And I think they decided yes, it would help retention. But two, are we going to recover any money this way? And the answer seems to be yes for us. I calculated the fees alone that we recover per section are $3,600, which covers the $2,800 certainly. And we also recover a bunch of tuition that would have been paid either to a community college where a student would have gone to take a remedial course or another institution where they might have gone to take college algebra. We're recovering a lot of that tuition. That's harder for us to calculate because we have a block tuition system. And so we're certainly recovering some tuition there, although it's not clear to me how much we're recovering. The biggest thing is, if we retain these students more, if we graduate these students more, that's a long-term investment for us, and that's a really good deal for OSU in the long run. Let me mention a few other co-requisite and curricular efforts that I think work very well in conjunction with co-requisite instruction. We really want to try to get non-STEM students out of college algebra. I think it's not an appropriate course for most of our non-STEM students. They don't need something so formal that's so rigid as college algebra and that is not as easily related to their degree interests, their career interests. The course we really like is our mathematical functions and their uses, which is our math modeling course, which is an alternative to college algebra. Every problem in that course is a word problem. It's all taken from real data. Uses technology, so uses graphing calculators or sometimes spreadsheets in order to model data and draw inferences from that data. It kind of sneaks in some calculus at the very end by talking about rates of change without really using the word calculus so that the students aren't scared off. I think it's a great prep for a conceptual business calc class, which is what we teach. And our social science disciplines have really liked it as a complement to their disciplinary statistics courses. So that one's been fantastic for us. It's grown a lot. We have about 600 students in it in the fall semester, which is getting close now to our college algebra class, still a couple hundred behind. For others, we encourage a quantitative literacy course, which is kind of a math potpourri, a math for poets sort of class where they learn some personal finance and some probability, a little statistics. That works very well for arts and humanities majors. We don't have a specific statistics pathway at OSU. Our statistics department is separate from our math department. And there are some complications there, but for those states that choose to have a statistics pathway, I think that's great too. One of the points of all of this is to be able to restrict college algebra to the students who really, really absolutely need college algebra. And, you know, if a student can't qualify for a college algebra course and they're kind of way far away, they're so far away that they don't really even qualify for a CoRec college algebra course for us, you know, that's a signal probably they should be in a different pathway. They might be looking at a different meta major, and they might be able to come over to a different path later on if they're able to get themselves up to speed, but they probably shouldn't be starting off on that one. So at OSU, what we've decided is our modeling course can satisfy the prerequisite for college algebra, even though they're not really closely related in some sense. We found that the data suggests that the students do okay if they take that modeling course and then college algebra. You know, I don't know that it's the best setup, but we've decided to do that as a way to help students who are in that non-STEM pathway and want to jump over to the STEM pathway. This semester, we're piloting a CoRec Calculus 1 class for at-risk students with a similar sort of format. We're trying to get students who, you know, do poorly on our early semester diagnostic. Instead of refusing to parachute down to pre-calc, we're trying to get them to accept the idea of a lateral move into a co-requisite class instead. That was an easier sell for us than parachuting back to pre-calculus. I hope that works. I don't know. I don't have any data on that yet, of course. We're introducing a new preparation for calculus course in fall 2018, which is going to be more of a conceptual pre-calculus class. We feel like cramming a lot of college algebra and trig into one semester, or just having students take trig as a prerequisite, is not working well for students. That they get too much in the weeds on that, and they don't learn the small amount of trig we really feel like they need to learn to be successful in calculus, plus more conceptual material about rates of change and what a function really is. The students in calculus really struggle with what a function is. They sort of understand, but they can't really parrot more than vertical line tests back to you a lot of the time. And the other thing we're doing is we really emphasize on coordinating the tutoring that's done in our Mathematics Learning Success Center, which with what happens in our classrooms. We were fortunate, we were in kind of a bad situation about 6 years ago with student success in lower division math courses, and the provost at the time was very enthusiastic about trying to change this and devoted a bunch of resources to doing so. And we built an 8,000 square foot math tutoring center on the 5th floor of the library in prime real estate on campus. And we have about 36,000 student visits every semester into that tutoring center. And we found that it's really helpful not only for students to get tutoring, but also to just talk to each other. We have big tables where they spread out and talk to other students in the same classes, and they develop a community that way. And I feel like they really are in much better shape if they've talked to some peers and they're able to find other people to study with and to work with. So that's been a big thing for us. So that's all I had in my presentation. I appreciate your listening. You're certainly welcome to email me if you think of things later that you want to ask, and also happy to take questions now in the Q&A session.
If anyone has questions, feel free to use the question function and type them in. We had a question earlier about what the DFW rate was, and I went ahead and answered that inside the question and let him know that that was students who receive Ds, Fs, or withdraw from a course. So we did get that one answered. Does anyone have specific questions about how this might work in Idaho at your specific institution? Feel free to ask anything. Okay, we have a question. What textbook do you use for the non-STEM modeling college algebra course?
It's a good question. We use a textbook that was actually written here at OSU in the mid-90s by Bruce Crowder, Benny Evans, and Alan Knoll. And I believe the title is Functions and Change. a modeling alternative to college algebra. That's roughly the title anyway. Functions and Change, a modeling alternative to college algebra. I think it's in its 6th edition now. I believe that's a Cengage publication. There are other textbooks I have seen used. I don't have any titles off the top of my head on this one, but that one for us has been very useful, in part because it was written specifically at OSU for the population we had envisioned, but also because the authors have been really good about every few years getting new data to put into the problems, refreshing the exercises, so that, so often you open up a college algebra book and there's a problem that was written in 1975 and it's exactly the same and it doesn't really appeal to the students at all. Since all of the problems in this textbook are word problems, they've really gone to a lot of effort to take things out of the news, out of current events, and try to get it so that it's interesting to the students. We've had a lot of earthquake problems in Oklahoma related to the oil and gas industry, or at least I think people agree on that at this point. I don't think I'm saying anything too controversial about that. And so some of the questions are about, the Richter scale, and trying to have students understand what's going on in the news, what people talk about when they're talking about different types of earthquakes. So that's the book we use. We feel like it's worked very well. It can be used either with graphing calculators or with spreadsheet software to do the data, and students seem to like doing both.
Great. We have another question. Have you considered allowing students that place below intermediate algebra to take the CoRec for college algebra?
Yeah, we have. And I think at this point, we're waiting to see a little more data on how the students at the bottom end of the placement range do. And to make sure that we haven't just had a fluke in the last few semesters, that those students getting 30, 31, 32 are really doing well. And if that's the case, I think we can drop it down. The primary reason we haven't at this point is because we didn't have enough personnel. So we were running 3 sections of college algebra in the co-requisite format already. And our big enrollment crunch is in the fall. We have 30% higher enrollment overall in lower division classes in the fall than in the spring. And so it was very difficult for us to just have enough people to teach the classes. We could have gotten enough undergrads, I think, but having enough actual instructors and adjuncts and everybody to teach those classes was too difficult for us. We also had an enormous classroom crunch. We could not find space to have these. And our central administration has generously agreed to build some new classrooms in part for this purpose, and I think that will help us as well. I would say, if I had to guess, as long as we can retain the right number of personnel that we need, we will probably drop that cutoff down in the next year or so. But we need to make sure we accommodate all the students who would have placed into intermediate algebra first. And then if we have room left over, if we have the personnel, then I think we'll go to dropping that cutoff a little bit.
Okay. This is a 2-part question. What is the typical number of students in the co-requisite course versus the regular course? And then, do the co-requisite students and regular students meet together on Monday, Wednesday, Friday?
Okay, good question. We, in the co-requisite, so all of our sections of college algebra are taught separately. We don't have any big lectures or anything like that. We have sections, our regular sections are basically between 35 and 40 students. And our co-requisite sections are 30 students. And those students just meet separately all the time. So when you enroll in a section of college algebra, you are in that section and you don't see students in any other section. So we do have them separated out. The regular students meet in regular sections, the co-req students meet with their co-requisite colleagues. We decided to do this in part because we wanted the co-requisite students to build a community, and we didn't want them to be intimidated by having stronger students in the class, and for there to be a temptation for the instructor to cater maybe to the regular students. I have seen other institutions where they did the exact opposite, and they really wanted that community. They wanted to integrate the students into the community, so they didn't have them in separate sections. We just felt like this was a better way to do it for our purposes, and it was a lot easier to have them separated out because we could have an undergraduate learning assistant go to the co-requisite sections and help out in those co-requisite sections. Whereas if we had them sprinkled out into other sections, it would be harder to identify where the learning assistant should go to help with special activities.
Okay. I don't see any more questions in the question box. So thank you, Dr. Francisco. Thank you all to the attendees for coming. Dr. Francisco, do you have any parting comments?
Yeah, let me just say that, I tend to be pretty skeptical of educational fads. And I think the thing that was most compelling to me that we needed to do something were the data that show how poorly students who go into the remedial track end up doing, that the remedial track just really isn't helping them at all. And I think we at OSU kind of felt like we didn't have anything to lose. Those students were not succeeding as it was, and we were losing them out of the system, and they weren't getting degrees, and it was causing them great difficulties, and it was causing us difficulties for retention and graduation, and we ought to just try something. The co-requisite data are pretty compelling, and I think there are times when people think they're too good to be true. I certainly thought that initially when I saw it, and for us, I've just been really amazed at how well this has worked, given that I don't feel like we're doing anything particularly innovative. We just have a setup that has worked for us.
Okay, you prompted another question. Are you allowing students to transfer from the normal class to the co-requisite class?
We are not right now because we have not had the space to allow that. In calculus, we do because it's set up that way. In college algebra, in our math modeling, we have not had the capacity to be able to do that. I think if we can expand the way I would like to expand in the future, and of course this will depend on personnel and whether we get resources to hire additional people if we need to hire additional people. I would like to be able to do that in the future. I think it's not that many students who want to go 5 days a week, but there are a few of them who are really conscientious and who say, you know what, I'm struggling right now, I really could use this extra help. And I don't like denying that extra help to a student who really wants it. I think it's important for us to accommodate that if we can, but we have not done that so far.
Okay, well, that's it all. Thank you so much for joining us. Thank you, Dr. Francisco, again, and I hope you all have a great weekend.